Hey everybody, in this video we're going to talk about solving a word problem using a 3x3 system of linear equations. Sometimes we have word problems where we're just dealing with numbers, and sometimes we have word problems where there's more of a application. So let's take a look at this first problem type where it says the sum of three numbers is 93. So let's just let x, y, and z be our three numbers, and we know they add to be equal to 93. Okay. The second equation we're going to pull out of this is the third number is 9 more than the first. So the third number is z is equal to the first number plus 9, or 9 more than the first. The next one says the second number is 4 times the third. The second number is y, so that's equal to 4 times the third number, which is z. So with these problems, our goal is to get 3 equations because we have 3 unknowns that we need to solve for. For this one, I am going to go ahead and put everything in terms of z, because I have y in terms of z, and x I could put in terms of z by subtracting 9 on both sides and getting x equals z minus 9. And then I can go ahead and plug in y here and x here in terms of z, and then I have one equation with only z in it. Let's look at it for a second. X in terms of z is z minus 9. Y in terms of z is 4z. And then I have plus z equals 93. So I'm going to end up getting 6z minus 9 equals 93. Or 6z equals 102. Divide by 6 and I get z equals 17. So the third number is 17. I can find, I'm going to actually go ahead and label that. I can find y by plugging in y here, or z here. So y is going to equal 4 times z, or 4 times 17, which is equal to 68. So y equals 68. And I also know x in terms of z. X is going to equal z, or 17 minus 9, which means x equals 8. When you are finished with the solving of these problems, we could, of course, go ahead and check our work. But we always need to make sure we refer our variables back to what the question's asking. What is x? X is our first number. Y is our second number. And we already put down that z was our third number. Okay, so that is one example of solving a word problem using a 3x3 system. Okay. So let's take a look at this problem, which is another 3x3 system problem, but we do have more of an application problem here. After winning $280,000 in a Beverly Hills bingo tournament, Devin decided to place his money in 3 different investments. A CD paying 4% simple interest, so let's go ahead and call this CD X. A money market certificate paying 5% simple interest, or Y, and some AA bonds paying 7% simple interest. We're going to call that account Z. After 1 year, she earned $15,400 in interest. Find how much was invested at each rate if $20,000 more was invested at 7% than 5%. So let's start at one place. we are placing this entire $280,000 into 3 accounts. So that means the amount in account X, or the amount in the CD paying 4%, we're going to say is X. And then we're going to add the amount in account Y and add the amount in account Z. And that's got to equal $280,000. Right? Now, how do we find the interest on these accounts? Well, after a year, we're going to earn $15,400. And remember, this is simple interest. So after a year, in account X, the amount of interest earned on account X is going to be 4% of the amount we put into X. The amount in account of interest earned on account Y is going to be 0.05 or 5% of the amount we put into account Y. And then into account Z, we put Z amount, but it earns us 7% interest. And then all of those interests added up was $15,000 and $15,400. Now we only have 2 equations here. We need one more. That's what this last little sentence is. Find how much was invested at each rate if $20,000 more was invested at 7% than 5%. So the amount in account Z and the amount in account Y. The amount in account Z was equal to the amount in account Y plus $20,000. Okay, so keep this picture in your mind. Remember what we're doing. And I'm going to go ahead and move to a blank slide so I can show this work a little neater. So here's my 3 equations that I have. If I were to multiply the first equation by 4, I would get negative 4x minus 4y minus 4z equals negative 1,120,000, like so. And then if I were to multiply the second equation by 100 to get rid of those decimals, I would end up getting 4x plus 5y plus 7z equals 1,540,000. Why did I do that? Because now I can eliminate these x's and I'll end up getting y plus 3z equals 420,000. But what did I know about z? I knew that z was equal to y plus 200,000, or 20,000, sorry. That's why those commas are important for these kind of equations. So all I did was, into this equation, I plugged in my z value from another equation. And then that's equal to 420,000. Now I can go ahead and solve for y. Multiply that 3 in. I get y plus 3y plus 60,000 equals 420,000. So I'm going to end up getting 4y equals 360,000. And then I'll divide by 4 and I'll get y equals 90,000. Now what was y? Y was the amount put into the account at 5%. But my third equation, didn't that tell me that z was equal to y, or 90,000, plus 20,000. So that means Z is going to be equal to 80,000. Oh no, sorry, 110,000. I was looking at the wrong one. 110,000. What about X? Well, I know that X plus Y, which is 90,000, plus Z, which is 110,000, equals 280,000. And this right here, 90 plus 110 is 280,000 or 200,000. After solving, I'll get X equals 80,000. Now, again, always tie these back into our problems. This is the amount in account Z, and Z was at 7%, right? That's that account. X was at 4%. So those are the different amounts that they had to put in to the accounts with those interest rates. And that's your examples for solving word problems.